So, have you ever stopped to think about how the AI assistant you chat with actually works? How does it go from being just a really powerful text predictor to a helpful partner that can actually hold a conversation? Well, today, we're going to pull back that curtain. It's pretty fascinating stuff. Yeah, it all really comes down to this one question, right? How do you teach an AI to have a real conversation? You've got this thing that's designed to just, well, guess the next word in a sentence. How do you turn that into something that can follow instructions, tackle complex questions, and be a genuinely useful partner? That's the puzzle we're going to unpack. And this slide just nails the difference. Look at this. On the left, you've got the base model. It just continues the sentence like it's copying from Wikipedia. Kind of dry. But on the right, that's the assistant model. It's engaging. It actually answers the question, gives you a cool fact, and then asks if you want to know more. So how do we get from that predictor on the left to the partner on the right? Well, the answer is a process called post-training. All right, so here's the game plan for how we're going to break this down. First, we'll look at the raw potential of these models, the prodigy and the problem. Then we'll walk through its two-step schooling. After that, we'll uncover the secret ingredient. Hint, it's all about the data. We'll check out some really cool advanced moves like model merging, see how they grade these things in a final exam, and then take a quick look at what's coming next. Let's get into it. Okay, first up, the prodigy and the problem. So imagine a pre-trained base model as this brilliant prodigy who has literally read the entire internet. It knows trillions of words, all the facts, all the concepts. But here's the catch. If you ask it a simple, direct question, it just kind of stares at you and tries to finish your sentence for you. It's got all this incredible knowledge, but zero idea how to actually use it to help. And that's exactly where post-training comes into play. You can think of it as the finishing school for our AI prodigy. It's the curriculum, the set of lessons that teaches the model to stop just predicting text and start being a helpful assistant that, actually follows your instructions. So, how does this finishing school work anyway? Well, it's basically a two-step process. You can think of it like this. We're teaching the AI both the hard academic rules and the social etiquette of conversation. Step one is what we call supervised fine-tuning, or SFT for short. This is like cramming from a textbook. The model gets shown thousands and thousands of high-quality examples of questions and answers, just to learn the basic format of a good response. But then comes step two, preference alignment. And this is more like learning social skills. It's where the model learns not just what a correct answer is, but what a good answer is. One that's actually helpful, safe, and gives you some detail. And this preference training is really all about nuance. Look at this example. The model is shown two different answers. Sure, Paris is technically correct, but it's a horrible conversational answer, right? It's a dead end. The chosen answer, though, it's detailed, it's helpful. The AI gets trained over and over and over again on examples just like this, learning to pick the helpful one and avoid the lazy one. And the methods for doing this are changing fast. The original way, called PPO, it worked great, but man, it was super complex and really expensive. It's like needing 3 different teachers. But a newer method, DPO, gets pretty much the same high-quality results, but it's way simpler and cheaper. It's more like having one great, efficient teacher. And this is a huge deal because it makes this super important step in AI training way more accessible to more people, which just speeds up innovation for everybody. Okay, on to our next section, and honestly, this might be the single most important part of this whole process. We're talking about the secret ingredient, good data. Because at the end of the day, you can have the most brilliant training methods in the world, but your AI is only ever going to be as good as the study materials you give it. So what do we even mean by good data? Well, it really boils down to 3 key things. First, accuracy. That's a no-brainer. The answers have to be correct. Second, diversity. You need to feed it a huge range of topics and interactions, coding, history, creative writing, you name it, so it becomes a real generalist. And finally, complexity. This one's crucial. You've got to ask it tough questions that force it to really think and give detailed, reasoned answers. For example, take a simple question like this one. How tall is the Eiffel Tower? This is what we call a low complexity prompt. It's just a simple fact lookup. The model doesn't need to do any heavy lifting to answer it. Now, compare that to this next prompt. Now, this is a high complexity prompt. See the difference? It forces the model to pull together information from different places, to compare ideas, and to build a really structured, detailed answer. This is the kind of stuff that trains a genuinely intelligent assistant, not just a glorified search engine. All right, moving on. This next section is where things get, well, kind of wild, almost like science fiction. We're talking about an advanced technique called model merging. And believe it or not, this is a real and powerful tool that all the top AI labs are using. And the idea behind it is actually shockingly simple. You can take one model that's been trained to be amazing at writing code and another model that's, say, a fantastic creative writer, and you can literally just average their digital brains together. And what you get is a new, single model that's great at both. It's incredible. And I just love this quote because it really captures how weird and wonderful this is. Even the experts think it's a funny idea that you can just take a couple of random models, mush them together, and out comes a stronger one. It's kind of like creating an AI super team. Okay, so we've trained our model, we've maybe even merged a few together. So what now? Time for the final exam. But how in the world do you grade an AI? Honestly, this is one of the biggest unsolved problems in the field right now. I mean, how do you put a number on whether a conversation was good? Well, there are basically two main ways people try to do it. On one hand, you've got your automated benchmarks. Think of these like standardized tests. They're fast, cheap, and easy to run. The big downside? They don't really reflect how people use these things in the real world. Then on the other hand, you have human judges, or sometimes even other AIs, who just rate which answers they like better. This gets much closer to what we actually care about, but man, it is slow, expensive, and full of all kinds of biases. And this brings us to a really, really crucial point. Those automated test scores, they do not line up with what humans actually prefer. It's a known fact in the field. A model can get a perfect score on its exams and still feel clunky and unhelpful when you actually talk to it. That's why you absolutely need both types of evaluation to get the full picture. All right, last section. Let's look ahead at what's next. One of the biggest trends happening right now is finding ways to make models smarter, not just back in the training lab, but right in the moment, right before they give you an answer. It's a bit of a mouthful, but it's called test time compute scaling. And one of the coolest techniques here is something called best of N. So when you ask the AI a question, it doesn't just write one answer and send it. Nope. Internally, it secretly generates a bunch of possible answers, like a whole handful of drafts. Then a separate judge model instantly scores all of them and only presents you with the single highest scoring one. It's like having a tiny, super fast editor living inside the AI, picking the best draft for you. And that really leaves us with a fascinating final thought. This whole idea of an AI that thinks by creating a bunch of options and then criticizing its own work to find the best one, that's incredibly powerful. So as these AIs get better and better at this kind of thinking before they answer, you have to wonder, what kind of new capabilities is that going to unlock? What new kinds of reasoning or problem solving will become possible? That is the super exciting question we're all waiting to see answered. Thanks for joining me.